Lurking within some vehicle cooling systems is an effect called electrolytic corrosion. In the automotive industry, it's better known as stray current. Stray current is a silent killer. It can cause severe damage to any component linked to the cooling system and often goes undiagnosed. Hi, I'm Ross. In this training video, we'll explore what causes electrolytic corrosion, how to test for it and how to fix it. Stray current occurs because electricity always takes the path of least resistance through a circuit. As current flows around the vehicle's electrical system, it will search out the path of least resistance back to the negative battery terminal. This can cause major corrosive damage to the cooling system, and as the current draw of an electrical accessory increases, so too does the destructive nature of the stray currents. Stray current damage can also be caused by static electricity, which builds up and finds its way into the engine cooling system. Static can accumulate as a surface charge in the range of thousands of volts, and even though it has no specific direction of current flow, it can jump from non-conductive to conductive materials. For example, suspension airbags have been known to accumulate static electricity as air flows over the surface of the bags, or as the bellows rub together. If this static charge then jumps across to the driveline and finds earth through the cooling system, electrical corrosion damage will result. Typically, the first sign of stray current corrosion is a small leak from a cooling system component, such as the radiator or the heater coil. There may be very little or no sign of rust or scale, just a pinhole, and then, as the impact worsens, visible signs of coolant seepage. A black edge running along the core tube or around the pinhole leak is a particularly sure sign that stray current damage has occurred. Plastic type intake manifolds are also susceptible to stray current attacks, degrading the synthetic materials and causing a coolant leak. To help reduce stray current corrosion, the automotive industry has a general set of specifications for stray current for both cast iron and aluminium engines. For a cast iron block, current levels should not exceed 300 millivolts in the cooling system. Aluminium engines are more susceptible to stray current damage, so should show no more than 130 millivolts. Due to a large number of variables, it's always best to check OEM specifications for the vehicle you're working on. Before testing for stray current, the vehicle should be at normal operating temperature, engine switched off and the radiator cap carefully removed. An analog multimeter with test leads and alligator clips is the best tool for testing. This is one test where digital multimeters are not as accurate. With the meter set to DC volts, attach the negative lead directly to the negative battery post and the positive lead to a small piece of copper tube. The positive probe with the copper tube is then placed in the top of the radiator coolant, being careful not to touch any metal. The small piece of copper tube is a better conductor than using the steel multimeter lead, so it will give you far more accurate results. With the engine and all accessories turned off, record the result. Now start the engine and turn on every electrical load you find. This will increase the alternator output and make locating any stray current easier. Start turning off each accessory one by one until you identify the problem circuit indicated by a higher than normal reading. Next, activate the starter motor. This test could reveal internal shorts, wiring issues and poor starter motor grounds. Follow with a charging system test. With the engine running and the RPM increased to deliver maximum charge voltage, record any reading on the meter. Now repeat all tests with the meter set to AC volts. These tests will detect any faults with alternator diodes or rectifier, as well as static electricity stray currents. If any results are above specifications, unsafe levels of stray current are evident and further investigation is required. To help reduce stray current corrosion, radiators in modern vehicles are effectively insulated by rubber mounts. This means that these days, grounding a radiator defeats the purpose of insulating the radiator. Likewise, cooling fans mounted to the radiator are best earthed directly back to the negative battery post. The most overlooked area that causes stray current issues is aftermarket accessories. Pay particular attention to high current draw accessories such as driving lights, extra cooling fans, winches and air compressors. Correct cabling size and good grounding points must be used. Regular servicing of the cooling system, along with stray current testing, is vital for reducing the risk of stray current corrosion. Ensure you use the OEM recommended coolant and only use deionised water in the correct ratio. And don't forget, as antifreeze breaks down with age, its active ingredients become more acidic, making the coolant more conductive and increasing the risk of stray current. You can now see why stray current corrosion occurs and how to identify it on a vehicle during a service. You need to be aware of the safe maximum levels of stray current. Early detection is important using a best practice methodical approach. I hope you enjoyed this training video. Keep training and thanks for watching.